Can you hear me?
Yes, sir.
Okay. A little bit about my background and biography before I start. I did my undergraduate BSc Mechanical Engineering from Bangladesh University of Engineering and Technology, which is known as BUET, in 1994. Then in 1996, I did my master's from the same university, Bangladesh University of Engineering and Technology. I completed my PhD in 1999 from Loughborough University in UK. Then I spent 6 years as a postdoctoral researcher at Loughborough University and University of Nottingham between 2000 and 2006. I joined Robert Gordon University as a lecturer in 2006, and until 2012 I was a lecturer. In 2012 I was promoted to reader position. Between 12 and finally became a professor in 2003. To say, before I move on to the graduate, I was the topper in my class. I was the first, both in my undergraduate study, MSc, and also my BSc, as you said, I was in less than 3 years. That was a great achievement at the time also. However, when I joined as a lecturer, I struggled to make progress in my career. So, though I was very good in academically, as I said, I was a class topper. But when you move on to the job, the situation becomes different. Okay, so in order to get promotion and move up to the ladder, you need different set of skills. Only the intelligence, only the knowledge, your academic background will take you so much. After that, you have to build up a lot of skills, primarily communication skills and also time management skills. Those are very, very important skills. And networking, knowing people, talking to them, their collaboration, those become very, very important. Also important is thinking innovatively, thinking creatively, and reflect how you are progressing your career. Unless you have those type of skills, it's very, very difficult to succeed in your academic career or any career, whatever it is. And I have since mentored and coached many academic staff how they can progress quickly in their academic life. And if you are interested to know that side of thing, I will be happy to discuss how can you build up your career without putting a lot of stress on yourself. Okay, so that's the key lessons. Now, a little bit about my university. My university name is Robert Gordon University. It is located in Scotland. If you are familiar with English or British system, we have England, Wales, Northern Ireland. These are part of Great Britain or United Kingdom. And then you have Scotland. So these are the four parts of the country. These are not independent and not federal, not like in India where you have state government. It doesn't have that, but it's just split into four different identities, as you see. Scotland is here. I am from Aberdeen, which is very, very up northeast here. Most of the Scottish people actually live around this one. We call it a central bay. And then we are here, and this area is kind of an empty space. Okay, and where I put my cursor, this area is full of oil and gas installation, offshore oil and gas. So these are the locations where you have offshore oil and gas. However, as you know, that we are moving away from oil and gas into renewable energy. So if I put my cursor here, these are the places where you have a lot of offshore wind energy. So Scotland is actually almost 100% renewable energy you can get over the year. Especially in summertime, many of the days you get 100% renewable energy coming mainly for offshore wind, and also hydrogen is another big area that Scotland is focusing their activity in terms of renewable energy. Our research initially started with oil and gas because it is a oil and gas hub. Our university was actually very well known for oil and gas type of research activity. But in recent time, we move on to renewable energy, and that include wave energy, wind energy, tidal energy, and of course hydrogen. So it's a combination of all type of energy research we are doing. In terms of our university, if you see here, it's a very small university. It has got only few buildings along the river. This is the river here. I will talk about the river later. This is the river D here, and our university is on the bank of the river. It is very narrow building because these are the locality here. So it's a very narrow university along this river. It's a very small university. It's a very modern university. In UK, many of the universities is 1,000 years old, and in Aberdeen we have two universities. Our university, Robert Gordon University, and University of Aberdeen. And University of Aberdeen is 400 years old. Compared to that, this university is only 40 years old. Okay, it became university in 1992. A very new university, not even 40, 30 years old or something. Okay, and these are, as I said, very modern building along the river. Keep in mind, in this river, I will have a question for you for this river. Okay, look at the figure here. Because we are our course is on hydrokinetics, and so river play a very important role. So keep an eye on this river here. Our student number is 16,000. Out of that, undergraduate is 10,000, and postgraduate is 6,000. We are number one in Scotland and number two within whole of UK in graduate employment record. What it means is that there are different type of ranking. We have, in university sector, some of the universities ranked on teaching, some of the universities ranked on research. You have other ranking system, QS or Times Higher Education. Our university is, as I said, in terms of employment, is number one in Scotland and number two in the whole of UK. Most of our graduate goes into employment within 6 months of our graduation. That's the statistics. Actually, in fact, most of our students goes into employment long before they completed their graduation. Last 6 months before they complete their graduation, they are into employment. They got the job before graduation. Why is that? Because our university put a lot of emphasis on problem solving and type of work that do in industry, which is innovation, problem solving, collaboration, cooperation, and this type of thing. So many of our study is based on project and individual study. We actually don't teach that much. We give a lot of problems to students, and then they come up with a solution and we discuss with them. Okay, that's the background. Let's move on to the topic that we are interested about, and that's why you came here. What we have is we are looking at hydrokinetic turbine, or other way to think about, we are thinking about how we can extract energy from river. That's the whole idea, how we can extract energy from river. What happens in the river? Water is flowing from upstream to downstream due to a pressure gradient, due to elevation gradient. Okay, and so water is flowing from unidirection, from top to bottom. Water flow in the river in a certain direction. Unless you are in a coastal area, unless you are in a coastal. Okay, something went wrong. Try to
What timing is Wi-Fi?
Get back. Thank you. So, we are trying to extract energy from a river that we talked about, or we started to talk about. Okay. What is the advantage of river? Is that it flows from upstream to downstream. So we know which direction water is flowing. Okay, that's a good advantage, because if you think about wind energy, we sometimes wind can blow from every direction. Okay, there is no predominant direction. It depends on the location, of course, but also wind can blow from different directions when river flows from one direction. So that's a big advantage. We know it's predictable. Okay, and if you look at this map here, there are a lot of river around in India, and if you think about this website, India WRIS, they looked at all the river energy resources in this website. So if you click here, it will take you to that website, and I will request you to use that website to find out resources of the river energy that has been there. So these are all the river map you can see, and all of them actually very good source of river energy. And in this slide, there is another big sources of energy, and that is from I think it's a Brahmaputra in Assam. Okay, and then this side is a lot of water resources. Okay, so to look at particularly what are the main river and localities, I put only 6, but there may be more. Something like Rishikesh in Uttarakhand, but there is a Ganges river. The Ganges river near Rishikesh has powerful, fast-moving current, making it ideal for hydrokinetic turbine. So that's a very good location, Rishikesh. Sambalpur in Odisha, there is a river called Mahananda again, and that is near Hirakud Dam. So what happened is, if you have already a dam there, and downstream of the dam, water actually flows at a very high speed again. And so you can make use of that resources further into extracting hydrokinetic energy. So on the one hand, dam is extracting energy from your what you call Kaplan turbine or Francis turbine and things like that, hydroelectric. But water then coming out at a very high speed out of the dam, and that energy, kinetic energy, that you can use also. Okay, Dam usually use potential energy. You collect water, you store water at a very high location, and then you use that potential energy. But further down in the dam, you can also extract energy from its kinetic source. So some Balpur in Odisha is a location that can be used. Do you know one thing? What you got? Is a good location here, Hirakud Dam, okay, for a hydrokinetic energy. Third place we are looking at Manali, Himachal Pradesh. There is a river called Bias River. It has got very high currents there again, high speed water coming down, and that could be useful for hydrokinetic energy. And one of the interesting thing about this Bias River is that it gets also water from snow melt season. So that's maybe after winter, when the snow is melted, lot of water again coming down through the river, and that you can make use of. So that's a very interesting location to look at. Then Bihar probably nearby. Here is a Supal. Supal is an area. Supal is a river called Kosi River. And that Kosi River also has a powerful flow, and that can be used for hydrokinetic energy. Then Bihar and Jharkhand, Son River, near Aurangabad, Bihar, and Latehar, Jharkhand. Son River, which flows through Aurangabad and Latehar, both in Bihar and Jharkhand, and has a significant flow dynamics during monsoon season. And this river middle section is a very good area for hydrokinetic turbine. And Brahmaputra in Assam, near Majuli Island. Brahmaputra in Assam, near Majuli Island. That's also a good place to put your hydrokinetic turbine. So these are the 6 areas you have. So I will request you now, not now, after this session, to think about which of the areas is you pick up one of those areas that you like or you are from nearby your place, and think about what type of hydrokinetic turbine you can put it there. So basically what I want you to do afterward is to look at how you can design a hydrokinetic turbine for a remote community near those areas. Okay, what you need to do is you need to think about the community you have with a water flow at 2 meters per second. If you don't have water flow rate of 2 meters per second or more, you cannot get energy continuously. So you need a quite a large velocity. 2 meters per second is actually quite not large, okay, and which is sustainable and reliable source of electricity. So think about that. This is your challenge. The community currently relies on diesel generator, which are expensive and environmentally harmful. Your task is to design a hydrokinetic turbine system that can generate at least 5 kilowatt of power to meet the community basic energy need. That means 5 kilowatt is not a lot. It provides lighting, provides charging devices, maybe mobile phone, few other charging devices, and powering small appliances, maybe some fan, some TV and things like that. Okay, so that's your challenge. This is the task I am giving you, and I would like to see it after the end of these 5 days. You design a hydrokinetic turbine for a remote community. So you need to do is understand the principle of hydrokinetic energy, you still don't know, I will go through and explain this theory. And then you have to think about how it differs from traditional hydropower. Then you have to analyze the relationship between water velocity, turbine design and power output, explore the environment and social impact, and develop problem solving and team working skill, hands-on design challenge. So this is your design challenge I am giving you, and I would like to see you come up with a solution after 5 days. So what you need to do? You need to sit down and brainstorm. And brainstorming you can do on your own, or you can form a group of your participants here, and then think about what are the factors that affect the efficiency of hydrokinetic turbine. What are the important factors that affect the efficiency? Then you think about what are the challenges might arise in designing a turbine for a specific location. That location is important. So I gave you 6 locations here, right? So each of these locations has a unique challenge. You have to find out what type of challenges are there for this unique remote locations. And then what type of materials and what technology you want to use for designing this turbine. Okay, as I say, to design that, what are the technical knowledge you need? We cover that one by one during this session. And each day, you take the knowledge from here and apply these, and you start to design your turbine for a particular reason. So, initial design stage. First of all, you think about what type of initial design we can come up with without even knowing anything. It can be a vertical axis turbine, it could be horizontal axis turbine, or it could be cross flow, or think about any type of design that it comes to your mind. Then what are the key components of a turbine? You need to have a blade, you need to have a generator, a blade and generator. You have to think about mooring systems. Okay, if you take a hydrokinetic turbine, how you can keep it in water? Okay, that's the key thing. Most of the time we are so busy with blade design from the mechanical or from the aerodynamics or hydrodynamics point of view. We are most interested in blade design. We forget about the mooring system. Okay, so you have to think about what type of mooring system you need. Think about creatively. So don't follow whatever is in the book or whatever you read. Think creatively. What type of blade shape can be, what size can be, how you orient it, vertically, horizontally, cross flow. So these are your initial design stage. Maybe if you do it after the in today's break without knowing any theory or anything, just think about how you can come up with an initial design based on whatever you have seen or whatever you have read so far before starting this course. Okay, and at the end of the day, the more material you learn, based on that, how you can refine your course that you can think of. Is that clear? Okay, good. So what you need to think about, I am giving you a little bit of pointer before you think about going into depth. You have to think about what is the physics of hydrodynamics, physics of hydrokinetic energy. What is the physics? What is the maximum efficiency you can get? That's an interesting aspect. What is the maximum efficiency you can get from this type of hydrokinetic turbine? That is called Bayes' law. Okay, we don't know. Anybody knows about Bayes' law here? Mahesh, you know?
Yes.
Yeah. So anybody else knows that? So you have to, yes, another one knows. Yeah, many of you know, many of you don't know. That's not a problem. But that's a pound, 2 lakh, 3 lakh rupee to put a turbine which will only generate 1 kilowatt. Okay, so you have to think about, we can have a very fancy engineering design, but whether you are economically worthy, that means you have to think about, okay, and from engineering point of view, again, we are actually don't think about this thing, cost benefit analysis too much. We are only like to look at engineering design or come up with engineering calculation and things like that. But if your design is very expensive, then okay, that may not be used ever. You have to think about environmental impact. What is that? If you put a turbine in a water, and that water is famous for fishing, so a lot of local people, they do fishing there, right? And if you put a water to if you put a turbine in that water, their livelihood will be disturbed. The fishermen, local fishermen, their livelihood will be disturbed. In that case, how can you manage this aquatic life? That means your turbine is not disturbing your fish. How do you ensure that? Okay, you have to come up with a design consideration that will not disturb aquatic life or the life of local people. If the life of local people is somehow affected, how you convince them that getting a electricity will improve their lifestyle significantly from what they are doing and things like that. So, human perception and acceptance of your technology. The turbine you come up with, whether people will accept that, whether the rural community will accept that. Because we talked about you have to design a hydrokinetic turbine for a remote community. So your turbine has to be for a benefit of a community, and that community is not accepting your design, then that is a big problem. You have to think about how you can convince them. Is that clear?
Yes.
So that's the task I'm giving you. You start doing it from today, and then as we cover more and more material, you try to refine your design. Okay? So that's the final design. We'll look at from you. Maybe I will look at your initial design tomorrow. You have a piece of paper, you take a piece of paper, you just sketch it, label it, just something like here, initial design. You do a rough sketch, your turbine design, label that with key component like a blade, generator, mooring system. Think about creatively. Don't follow what is there. Come up, if you can, not necessarily you can come up with a new design, but if you can, think about blade shape, blade size, blade orientation, and try to come up with a design to begin with. And then as you learn the theory, you go on, refine that design. You have to think about base law, very important. You have to think about how we can calculate power. Okay, our design brief says how much is the one? 5 kilowatt turbine. We want to design 5 kilowatt. How big that is? This much or this big? 5 kilowatt turbine. Think about how we can find out 5 kilowatt and 2 meter per second is water flow rate. Okay, so you have to think about in these locations where is that 2 meter per second of water flow rate you can find. Okay, and then you come up with a initial design, do some calculation, find out First of all, you sketch just freehand. You cannot say, you don't need to say this is 2 meter or 5 meter or 8 meter. You just come up with the design first. Think about what are the components of a hydrokinetic turbine. Then, as you know the theory, you can say, okay, I need 2 meter, I need 4 meter for 5 kilowatt design. Okay, so maybe tomorrow or maybe after the break, I will check some of your initial scale to see what is your thinking in terms of hydrokinetic turbines. Okay, it neither has to be right or wrong. There is nothing called right or wrong. It's just an initial design idea. And once we learn more, we can then move on to creating actual design. Okay, so now I move on to actual theory a little bit. So that will refine your initial design. Okay. So we are thinking about rotor design. Let me see. It is my no, not this one. Go back to another slide. Okay. Go back to another slide. Okay, so that's the design aspect. I'm not giving you the theory right now. So I want to see you think about the design first before I give you the theory. Okay, so that's why I move on to another slide to talk about a more generic introduction. So what we are talking about, why we are actually interested in hydrokinetic turbine? Why? Why is that? Because we have electricity, we have air conditioning, we have fan, we have car, everything is fine. Why we need hydrokinetic turbine? What is the reason? The reason is very simple. If you think about in the world, there is a growing population, number one, and then there is a growing economic improvement. For example, I can say my lifetime, in my own lifetime, when I was in a school or in a even at university, not even university, when I was working as a lecturer in Bangladesh, the quality of life or standard of life we had at that time, and now after maybe 20 years, changed completely. We never had a mobile phone, we never had all the kind of middle class quality of life, not even in 2000, early 2000, in Bangladesh I'm talking about. Yeah, but the quality of life has improved significantly. In my lifetime, I have seen that. So, global population is going up, number one. Number one, quality of life is going up. What is there in the Western countries, that all is seeping through to other countries. Okay, and we cannot stop that. Okay, everybody needs a decent quality of life. That includes driving a car, maybe having air conditioning at home, maybe. So that actually creates a lot of energy demand. Okay, and that energy demand, how we can meet energy demand? Simple, oil and gas. We have lot of oil and gas, we can burn oil and gas, and then we can continuously get the energy that we need. However, the downside of oil and gas burning is you produce a lot of carbon dioxide, and you have carbon dioxide emission continuously going up. So, increased population, increased quality of life, your demand of energy going up. And what's the problem with that? We are emitting a lot of carbon dioxide. As a result, we can already see impact of global warming. We have seen prolonged drought, cyclone, flood, sea level rising, and extreme heat events. So time to time we hear that temperature is very high in some part of India. And you may, in your life experience, you may notice that compared to 5 years ago, it's too hot. summertime is very hot, very unbearable. Okay, so that's your personal life experience. You can think about. If you don't believe the scientists, lot of politicians don't believe the scientists either. Okay, when we are talking about global warming, instead of going into that discussion, if you think about what's happening to my life, am I feeling heat stressed during summertime? I'm feeling more and more hot during summertime, and that's the proof of your own experience. Is the experience changing over year after year, based on this global warming? You may say that. We can see increased food and water insecurity. It can happen because of sea level rise. It can happen because of prolonged drought or cyclone. Those type of events can lead to food and water insecurity. And then you can have damage to fresh water, coastal and ocean marine ecosystem. So a lot of things can happen due to global warming. So what you can do? So we know what is happening. Global energy use always grows with population and GDP. So there are two things: population growth, number one, and number two, GDP growth. And there is a linear link between global energy demand and growth. Okay, GDP is growing in many countries now. If you think about Western countries like UK, GDP growth rate is almost flat line, 0.1 plus 0.1 minus 0.1, because they have developed and then there is no growth anymore in the economy. Whereas many other countries is developing at 6, 7%, 8%, right? Okay. So we are actually producing more and more energy, to be honest, but it's not enough. Okay, because we have billions of people who still don't have access to affordable and reliable energy. If you go to South, if you go to African countries where there is still not enough affordable and reliable energy, okay? Global South. And in future, population growth will overwhelmingly concentrate in the global South. That's what I was talking about. And energy consumption will also grow. Economy is progressing even in African countries. I was recently in Kenya. We are doing a project in Kenya on heat stress. We talk about feeling hot. So that type of environment, we are trying to create some passive cooling. But those countries' population growing, they are in their structure, remote areas. If you compare that from say India condition here, they are far behind in terms of quality of life. So those will obviously improve, and that will demand more energy. So economic growth, we need to have energy supply, infrastructure development. That's given. That we know. Do you need to do anything to looking at future? We have to move to sustainable energy. Most of the climate change disaster, to prevent that, we need to move to sustainable energy. That's for sure. Because we have to keep risk of climate change. First of all, how you do that? You can manage that by reducing carbon dioxide emission. First of all, you think about how we can reduce emission by changing your lifestyle or changing few things here and there. You can reduce carbon dioxide emission because you want to keep the carbon dioxide temperature rise below 2 degrees. Then we need to move forward immediately, massive and sustained effort in reducing carbon dioxide emission. So we need immediate, now, massive and sustained effort in reducing carbon dioxide emission. And to do that, by changing the way we live or making few changes here and there, will not help. Okay, you need to come up with rapid transition to sustainable energy system. So that's the key. Wind energy, wave energy, or hydrogen, that type of system we have to move quickly. Okay. So suppose I don't know you experience it or not before. So you are in this room. We have the light here. If you go out of the room, what do? Do you switch off the light instantly? If you switch off the light, that means you change your lifestyle a little bit. Because I noticed before, nobody is switching off light. You are in the room, light is on. If you go out of the room, you keep the light on. Okay? And then you come back to the room maybe after half an hour. But if you change your lifestyle a little bit, every time you go out of the room, you can switch off the light. And you can keep your light point near the door also, right? That's another way of changing your behavior, that keeping the light near the door. So once you go out of the door, you just switch it off, go out, come back, switch it on. Okay? But it was not like that. Even if I take my experience in Bangladesh, most of the switch is far away from the door. So at evening time, you switch on light, whole house, whether people are staying in that room or not, it doesn't matter. Whole house you switch on the light at night. But not in UK. When I went to UK, I noticed that only you switch on the light in the room you are staying. So if you are in the one room, in the living room, you just switch on light on that room, whole of the house is in dark. Okay? But when I was in Bangladesh, I remember that all the light is on when you are, whether you are inside the room or not, it doesn't matter. Evening time, just switch on light. So that lifestyle change is important to reduce carbon dioxide emission. Okay, just switching on light when you need it. But there are other lifestyle changes you can make to make sure that you reduce carbon dioxide emission. But that will only help so much with the population growth, with the economic growth. You need to move to sustainable energy system. Okay, so we can see that sustainable energy system is actually picking up now. If you think about the US, whatever $1 they are spending on oil and gas, they are spending 1.8 in green energy. Okay, so even in USA, where sometimes we hear from politicians that they are against this renewable energy changes and things like that, but also they are investing quite a large amount of money in clean energy technology. This increase is actually concentrated in advanced economies and in China. China is also moving rapidly into what they call new energy. In China, the term used is new energy. And they are moving rapidly into those green technology or clean technology, whatever you call it. Okay, and many of these has got what you call net zero emission target. In Scotland, we have a law passed in the parliament that we have to reach zero emission or net zero emission by 2045, where in whole of UK the target is to reach net zero by 2050. I think India has a target something like 2070 or 2080, something like that, to achieve net zero. Okay. So clean energy is taking shape, is progressing well. There was a historic link before that economic growth, GDP growth, and fossil fuel demand was linear. From 2020, I think that the link, economy is growing, but the fossil fuel use is not growing proportionately. There is a link between GDP and fossil fuel demand. That link is broken from 2020. Okay, and so if you look at what are the clean energy happening currently, you see the solar PV. So this is the target. This is the target here. Solar PV already well ahead of the target of 2030 target. Use of solar PV is actually quite at an advanced level, well above the target. Obviously, solar is intermittent and it will not be able to provide 100% of energy. All other energy target is below. So these are the below line. Okay. So only this line surplus this line. This is the solar technology. Okay. Other technology are well behind there. Okay. So what are the other technology there? What are the other renewable technology? So if you look at here, hydropower will remain the largest renewable electricity source by 2028. Hydropower, this color here, blue color, light blue color here. So whatever happening in solar, whatever happening in other sector, hydropower is a very important one. Interestingly, hydropower remains the largest renewable source of electricity generating more than all other renewable technology combined. More than all other technology combined, hydropower is still higher than, if you think about here, hydropower here more than other renewable technology. And in net zero scenario by 2050, we are talking about the world estimate, 5,500 terawatt hour of electricity per year will be produced from hydropower. Hydro, water. So this name of the course, if you think about name of the course is Unleashing the Power of Water, right? So we are looking at water has a lot of power. How we extract that? Still, hydropower will be a dominant renewable energy source. So what is the current hydropower? What is the current hydropower? Current hydropower is what we call hydroelectric system. What is that? We create a dam in a river, we collect a lot of water, that give you a high amount of body of water. And then we take this body of water through a pipe, penstock, and convert that power into some sort of either kinetic energy or pressure energy through a turbine blade. We can have Kaplan turbine, we can have Francis turbine, we can have Pelton wheel. These are the three traditional type of turbine hydropower. However, there is some problem with hydropower. Main problem is ecology. Ecological problem. What is that ecological problem? Because you block the water body, okay, and then you release the water downstream. So all the processing of fish we are talking about, the flow of fish is disturbed. If you store water in a big reservoir, where you have to create a reservoir upstream of the dam, and that will take a lot of land uses and things like that. So it can create some problem to the remote communities also, those who are not getting the their livelihood may get destroyed because of the water collection and things like that. Okay, so for example, if I go back to Bangladesh again, so in Bangladesh there is only one hydroelectric power plant, and that is in a place called Kaptai. And that hydroelectric plant, when it was established in 1916 or things like that, that flooded a massive community of indigenous people. Okay, we call it Chakma people, who are kind of indigenous in that area. What happened? Even the Chakma king, there was a king there, and his palace was flooded, and a lot of the communities, their own house was flooded. They used to live at the bottom of the hill. They have to move up the hill because lower part of the hilly area was flooded, and that created a big resentment among the community, and then they even fought against the Bangladeshi government with arms and things like that. Okay, so that created social and security, lot of other type of problems. So this hydroelectric power plant is not very attractive these days because of the environmental consideration. Though it is 100% renewable energy, but it is not attractive any more because of the ecological problem, and also it can create a social problem. Most of the power plant is actually built in 1960s to 1980s, as I said, and these are very massive actually, and these are becoming very old. So it is almost like 40 years old or 60 years old. So after that, you have to decommission or you have to do something, maintain, to refurbish and to increase their lifespan. Okay, so even the turbine blades, generator, these are 40 years old and this is corroded, eroded, so you have to replace and things like that. Okay, so that's the challenge coming up very soon, how we can maintain that. And also, you can use digital technology now to increase their plant flexibility. Because if you think about renewable energy, these are intermittent. It's not available all the time. So managing, combining different sources of energy is a critical challenge, how you combine those type of technology. Okay? So to do that, you need to innovate. You have to innovate. We know the technology, almost 150 years old. Technology itself, 150 years old, hydropower. Before that, we may have inefficient power, water mill and things like that, rotating a big wheel, and you are not generating electricity, but doing some source of work. But that become a technology, inefficient technology, but we have more efficient technology, which is more recent. But innovation is the key. So, where the innovation is needed is a turbine blade design, that innovation is needed, and operational pattern, that is also needed, and digitization. So, you can make a flexible plant. That's the important thing. How you can combine different types of renewable energy sources flexibly. So you have to, if you think about hydropower system plant, how you want to innovate, you need the modern power system with variable demand. Now we are thinking about variable demand and increasing penetration of intermittent renewables. So that's the key thing. We have renewable energy, which is intermittent, which is not available 24 hours. How you balance that with your new innovation. That's the key. Okay. So I think we have talked quite a long. I don't know whether you are allowed to give a break or something. Anybody knows anything about the break? 5-minute break? You allowed? Yeah.